And then it's like, I like, it's like. It's just.
No, this is like,
It's
just like some of the.
I'm gonna wear a shirt.
Oh, yeah, they
London today. Because I learned about London.
they take pre-treated South Carolina. So.
First of all.
Okay, welcome back, guys. I'm gonna be checking, I'll check pages, 1 through 20, well, some students haven't shown me page 1 through 8 yet, but, I do need to check page 9 through 23 from packet 2 to 3. I'll do that at the end of class. I've graded your, FRQ test, I just needed the homework grades to add into your test grade. So I'll try to, so once I check your homework today, I should be able to get that in the grade book. If not today, then sometime tomorrow. Okay, so let me go through the calendar on page 2 of your packet.
Right now. Yeah, I don't think I have a team. Oh, I took that. And now. Wait. Wait.
It's also under 2. Maybe have too many people.
It opens up.
I finished the first packet. I just left it up. Like I wasn't working on it, so I forgot to bring it. Another day.
Yes.
Okay, so let me go through. Let me go over the calendar. So we started on packet 3 yesterday. We worked through pages 1 through 3, problems 1 through 3. And today, we're just going to be continuing working through polar FRQ. So tomorrow, I'm going to be checking pages 1 through 13. But I think we can get through a good chunk of 7 through 13 in class, and then you guys can finish the rest maybe to check. So this whole week, we're just going to be focusing on polar FRQs and a variety of kind of BC topics from FRQs. So I call it just miscellaneous BC topics FRQs. So sometimes they may include integration by parts, or improper integrals, or partial fraction, or Euler's method, logistic models, arguments. So I try to give a wide variety of different BC FRQs that include some of these topics. So your quiz will be next Tuesday, and it'll just be one of these FRQs. It'll be one polar area and one miscellaneous BC topic. But then this miscellaneous topic could be within another type of FRQ. Could be under a solving differential equation FRQ, could be under a Riemann sums FRQ, could be under particle motion FRQ. So we kind of see that, you know, it kind of falls under a wide variety of different problems. But we'll get a chance to practice through them over the course of this week. I also included some various AB topics just for practice purposes, since your AP exam will share 3 AB FRQs with the AP exam. So I don't want us to forget those types of FRQs. So we'll also practice 2 particle motion, Riemann sum, rate in, rate out, antiderivative FRQs. Okay, but your quiz next week will just be one of this and one of this. Okay. Okay, continuing with our calendar. Packet, so right now you guys have packet 3 that you picked up. Packet 3's homework classwork will account for half of your quiz grade. So 50 points will come from your homework, 50 points will come from your quiz, and that's next Tuesday. After that, we're going to shift over to preparing for our multiple choice test. So I'm breaking up into 2 days. I'm breaking up into the first day being just AB topics. I'm changing it slightly. It's gonna be 15 questions, 1 to 15 be 30 points. So we'll spend most of next week practicing and reviewing multiple choice. I mean, the fact that we've been doing, all these FRQs, it should, we should have to basically review. Okay, I think we know our AB topics pretty well, but it's still good to have days to practice through all that. And then I think if we get done with this by Friday, maybe we can start our the second part of packet 4, which is BC topics. So we'll do some of that on Monday, Wednesday, Thursday, and even Friday, because what I want to do is I want to push this second portion to Monday, because these Tuesday will be a full class period, but Monday, Wednesday, Thursday, Friday are going to be slightly shortened due to EOCs. So I'm going to push this out to Monday, have a full class period for you guys to work on part 2. And this one will be 10 multiple choice questions, 20 points. Okay, so there's 20 points here, 30 points here. Your packet 4A, packet 4B will be 50 points. That'll be 100 points. That's great. Okay, so that'll be the last remaining assessment that you'll take in class. So we'll get done with that before May. Oh yeah, that Monday before May. And then we have remaining 2 weeks in May before your AP exam. So that first week of May, we'll take our AP multiple choice part 2 on Monday, and then I may even go ahead and start. I may swap Monday and Friday around. Go ahead and start our FRQ here. But we'll be working through a packet 5. So packet 5 will just be the most recent FRQ exams that College Board has released. So from 2016 to 2023. And we're just going to work through it. And whatever we don't finish in class, you'll finish with homework, and I'll be checking. I'll be checking 6 pages or 6 problems per day. And that your packet 5 will count towards the quiz grade. It'll be just a completion grade, but you'll get a full quiz grade out of it. And then the second week of May, this is when AP exams start, the first week of AP exams. So a lot of students will be in and out of the classroom, but in class, we'll be working on packet 6. Packet 6 will just be a variety of multiple choice exams that College Board released, in addition to just some AP classroom problems that I found. So I'm going to put that into the packet and have you guys work on it. I'll try to give both packets 5 and 6 together. So if you want to work ahead of time, because I know that the 10th is senior's last day, so may decide that you want to show me the packet before Friday. But there is no, I'm not going to be checking packet 6 on a daily basis. There's no late penalty. As long as you finish packet 6 sometime before the end of the school year, I'll be able to give you 4 credit. That'll be another quiz grade as well. Okay, so our remaining grades, I'm gonna put the test grade in, today if not tomorrow. And then we have a quiz coming up, a test coming up, and then 2 take home our, completion grades, quiz grades. So that's what remaining for our school year, these remaining weeks. Any questions? And then on the FRQ quiz and on multiple choice test, I'll let you use your calculator. I will indicate, which is a calculator question and which is not, so that the ones that's not, you can, I'm gonna ask you to show your work. So on the multiple choice test, I'm gonna be asking you to show me your work, so I can give you partial credit. So yeah, just be aware of that. Okay. Yesterday in class, we worked through problems 1 through 3. So why don't we pick up at page 4. See if we can get some practice in here. So page 4. Okay, let me read the problem and then have you guys give this a try and we can talk about it and compare our answers. The graphs of polar curve r equals 2. So r equals 2 is going to be the circle that's centered at 0 and it has a radius of 2. And then r equals 3 plus 2 cosine theta. And we see that mainly in that first and fourth quadrants. Right. The curves intersect at theta equals 2 pi over 3. So 2 pi over 3 here, and then 4 pi over 3 here. Let R be the region that is inside the graph of R equals 2 and also inside the curve of R equals 3 plus 2 cosine theta as shaded in the figure. Find the area of R. Okay, so go ahead and try that. Remember that polar area, we're always sweeping out counterclockwise from the origin, right? From polar 0. And as we fan out, we're going to kind of radiate and hit the edges of the curve. And as we sweep out, we're going that's how we accumulate our sector regions, area regions, and that's how we eventually get to our area. So. And what I like to do is I like to take advantage of symmetry. And if I can take advantage of symmetry, then I only have to find a portion of the region area and then just double it, right? Or so that way I don't have to figure out all these different intersection points. So as long as I know 0, 2 pi over 3, and pi, I can pretty much create half of the area that I'm looking for, and I can gather the other half just by doubling. So here, I decided to take advantage of symmetry here, and I just took care of that region that I saw in the first two quadrants, the quadrant 1 and 2. I know that from 0 up until 2 pi over 3, it's hitting that circle. So I can just say 1/2 integral from 0 to 2 pi over 3, 2 squared d theta. But then after 2 pi over 3, it's hitting the limacon. So I need to switch over to a different different equation. 2 pi over 3 to pi. Formula is 1/2 integral r squared d theta. But I'm doubling it because I'm not doing the third and fourth quadrants. You could, but to me, it's easier to just do half of the problem and doubling at the end. If you don't use symmetry, that's fine. I didn't show the work for that, but we should still get the same answer. We should still get 10.37. So if we didn't want to do symmetry, then we would do 0 to 2 pi over 3, 2 pi over 3 to pi, pi to 4 pi over 3, and then 4 pi over 3 to 2 pi.
For the previous packet, for some of the area problems, like, I don't think for the, very weird looking curves, I don't know, like, how you figured out the bounds.
Right. Which page?
22, problem 47.
I think we have to just use our calculator, and then if you change your window to theta, if you change that theta max to pi instead of 2 pi, then you're going to see that pi is only going to graph half the graph. If you go to 2 pi, it's going to draw the whole graph. So you're going to use that to help you decide, okay, that full cycle is going to be 2 pi instead of just pi.
It's the same thing for the curve on the two curves on page 23. 49.
Yes, yeah, you would, yeah, test between pi and 2 pi to help you see that. Yeah, okay. Yeah. So thankfully, on polar problems, they, if it's something that is not easily identifiable, usually a calculator question where you can kind of play with that. Okay, part B, a particle moving with non-zero velocity along the polar curve is given by r equals 3 plus 2 cosine theta. This particle moves along the curve so that dr dt equals dr d theta. Find the value of dr dt and interpret your answer in terms of the motion of the particle. So we know dr dt equals dr d theta, so we can just find dr d theta. Dr d theta, we can just find the derivative, plug in pi over 3, you get a negative 1.732. So our radius is decreasing. And we know the radius is greater than 0. So that means particle moving closer to the origin at theta pi equals 3. And for part C, we can build our y in terms of theta and then do dy d theta. We get a positive number. So we know that our particle is moving away from the x-axis. Go to problem number 5, if you're good with that. This is meant to be non-calculator, so sometimes you may not know where the graph starts and where it's hitting the polar zero. So I think the best way to do it is just go ahead and start building out ordered pairs. The graph is in front of you, but go ahead and build your ordered pair. Start with 0. Find some easy unit circle values to plug in to help you see the path of the graph and where it hits that polar zero, where it hits that y-axis. So at 0, my radius is -1. Pi over 3 is at 0 because cosine of pi over 3 is going to be 1/2. 1 minus 2 times 1/2 is 1 minus 1 is 0. So we know polar 0 is at pi over 3. So we know that that shaded region is going to be from 0 to pi over 3. If I continue building out, I can see my important points on this graph, right? Pi over 2 is at 1, and then at pi is at 3. Part B, write expressions for dx d theta and dy d theta in terms of theta. So we can build r x equals r cosine theta, replace r with theta, and we can find the derivative. Again, non-calculator, so we want to show all of our work here. Once you build out your x in terms of theta, you can go through either product rule or you can multiply through and go through quotient rule. Either way, which you get to the same derivative. Part C, write an equation in terms of x and y for the line tangent to the graph. So somehow we want to just be able to get our x value, our y value, find the derivative, find our slope, and then point slope form. Just like parametric, you can split up your dy dx into dy d theta over dx d theta. We can pull dy d theta, dx d theta from part B and find the slope components from part B. Okay, if you're good with 5, go to number 6.
This is gonna be number 5 on the exam.
I'm sorry.
This is gonna be number 5 on the exam. Follow your. or it can appear anywhere.
Oh, you mean on the AP exam?
Yeah.
It could be either, I typically see it as number 2 or number 5.
Okay.
Yeah, but polar area has been, it's not every year, it's like once every 2-3 years it shows up. But it's still, polar area still comprises of like 10% of the AP exam. So if it doesn't show up on the FRQ, it means it will show up more on the multiple choice.
Wait, just polar area alone is 10% or the whole unit?
Yeah, the whole unit, sorry. Polar, yeah, polar unit is 10%. Okay, so here's number 6. The graph of polar curves r equals 3. That's going to be your circle that's centered at the origin with a radius of 3. And then you have the limacon 4 minus 2 sine theta. The curves intersect at pi over 6 and 5 pi over 6. Let S be the shaded region that is inside the graph of r equals 3 and also inside the graph of r equals 4 minus 2 sine theta. Find the area of S. If we look at this and understand that pi over 6 is 30 degrees, and you have 90 degrees plus 30 degrees, this is going to be 120 degrees. This is basically accounting for 1/3 of a circle. So I know that the shader region is going to involve 2/3 of the circle, and then the top portion is where the limacon is hit. So we don't technically need the area formula for that portion. If we don't want to, we just think of it as, well, that's just 2/3 of a circle, 2/3 pi r squared. That will get me to this region and this region. And then the limacon is just pi over 6 to 5 pi over 6, 1/2 r squared d theta. Now, I do want to point something out here. If we really wanted to do something in this region, though, how would you write this out? We write it out this way. I have my balance being this. No, that's not connected, right? I mean, if I really want to do this, I need to make this what? I need to make this negative pi over 2. So just be aware of that. Sometimes, you know, we want, I think of this as something connected. Or if you want to start at 3 pi over 2, then you need to make this. You make this 13 pi over 6, right? You make it a connected interval. We can't go from 3 pi over 2 to pi over 6. That's then you're jumping and you're doing something backwards. Part B, particle moves along the polar curve so that at time t seconds, theta is t squared. Find the time between 1 and 2 for which the x coordinate of the particle's position is -1. So build your x of theta, replace theta with t squared, and then replace -1 for x of t squared. And then you can just graph and look for the x-intercept. Let's keep working for 5 minutes and then I'll come check your homework 5 minutes. From packet 2. Okay, page 7, number 7.
My answer is like rounded 1,000 off.
That's fine.
That's fine.
Okay, so for your previous packet, if I can check pages 9 through 23.
Oh, since I didn't have it.
Okay. See, I have 1 through 8, but you still working on this.
Finish the first one, it's just at home. I'm measuring lines.
Got it, okay.
I'm sure one will, I will find the intersection and the X value, Y value, it's not a battery. Okay. It's a normal, I think that has some standards.
I get that. Sure. Then
Yeah, I'll go over that with you.
Like, I don't know. You know, because then you have to like. Think about it out. And they'll play money. I think. There's like a lot of people regular trying to. So, yeah, I would. Okay. And you're like, kind of. That's unfortunate.
Okay.
Yeah, I'll make like part of by tonight.
Okay.
Honestly, I think they're just.
Oh, yeah, I said
why. I can think like, I can do it or something. Or like, I think Dave, until the day of the first competition, I didn't know. It's fun. I'll have to. Hopefully, there's something that moves. Thank you. This is the advisor very long for these two practice exams. Oh, no. Yeah, that's right. Yes, I know. Very.
We're worried. Yeah, bro, it was actually.
Oh, so good.
Eight practice exams. Latter day.
Yeah, the transfer. Yeah.
Okay. I'll probably have music video, but that's chill. Oh wait, you wanna hear a song?
That's right, we should.
No, less than.
A new one?
There.
Yeah.
Oh, they did.
Yes.
Why?
Yeah.
Yeah. Forgot what you said. So.
Okay, so I guess that's why.
He's here.
I know.
Well, it's like, see,
You're still working.
Yeah, I'm still working on it.
Also, thanks for all. Probably told the high boy, that's cool.
Okay. Yeah. What do you need?
it's like, I don't remember what happens lawyer.
I didn't understand.
Hospital.
But she lives like.
Oh, and it's genetics.
What, and what are you gonna do with UFC?
Did you want to watch people career? No,
I thought it was funny. Is it like, you're like. That's great.
No, I'm not even, we're like, technically, like, yeah. I'm gonna study for everything else.
You get a chance to do it, you know, so.
I know you, bro. Well, it's part of that. My best work is always like, like 50, 60, 70. But he submitted all the details to me. Right, you're like, tripping right now. So you just have to be more. Yeah. Not really. That's like, oh my god. No, I'm excited to get the second. Crazy, I got the second. I think I just kind of. It's rounds, they started. How do you really think that? I say maybe kind of thing. It's doing something every day before. Yeah, but I can do it through like, oh, you have to do something. It's like a man. I figured out that bench, right? Yeah.
Yes.
Oh. It's controlled me.
Yeah.
Still like done with this last minute. The day you were just you and like I saw it. You were all space. Kind of like, if I just go to a small talk Friday, I would have been able to run another one. But if I didn't go to the before Friday, I wouldn't have.
There's like like was the highest that he's like. Drive the.
Like during that everyone was in that sort of reach. But there's no other so we all have these bigger goals for every single time. So basically,
Yeah, I was thinking of like pursuing a career.
I care about the ball.
Yeah, maybe offer some career.
No, I mean, like, if I missed it, that's.
Like, what's the thought?
Yeah, so it's like they don't really.
Oh wait, someone edited it. Like someone makes it a song. Stuff.
Like, no, don't. That's no, okay, but like nobody does on the day. I do it on the day. I just submitted like 5 days. If you roll,